today then. We are finishing Chapter 6 with 6.7, Solving Radical Equations and Inequalities. So I need your attention up here, please. That means next week when you come back on Tuesday and Wednesday will just be review of Chapter 6 and then the Chapter 6 test. I don't have it written on the board yet, but Chapter 6 test will be on Thursday next week, just so you can plan for that. So we're going to start out with solving radical equations. These were introduced, solving radical equations, at the end of Algebra 1. So some of this might seem familiar. We've talked about methods in terms of solving equations with radicals already a little bit. This is more formally explained. So a radical equation would be an equation that would contain a square root or a cube root or so on, so a radical. And we know that raising something to the second power or squaring something would get rid of a square root. So you can solve a radical equation by raising each side of the equation to a power. You just have to determine which power makes sense. So I do have this key concept box on here. We'll talk through those 3 steps as we go through some examples. But then what I do want to point out is sometimes when you solve a radical equation, the result you get may be a number that doesn't satisfy the original equation. So such a number is called an extraneous solution. It is very important when you solve radical equations that you check your answers, because it is possible you will get an answer that doesn't actually work in the original equation. It just works in the equation you're getting after raising both sides to a power. So if, say, you give the answer x equals 3, because you didn't check it, you're going to lose points if it doesn't actually work out. So we're going to look at example A, and like I said, I'll talk through these 3 steps. So the first step when you solve a radical equation is to isolate the radical on one side of the equation as long as you only have one radical. So if we look at example A, I want to get the square root of x minus 2 by itself first. So to get rid of the minus 1, I would have to add 1 to both sides. And that means I will have 6 equals the square root of x minus 2. Once you have the radical on one side by itself, the second step then is to raise each side of the equation to a power equal to the index of the radical to eliminate the radical. So to get rid of a square root, we have to then square or raise each side to the second power, square both sides. And that'll cancel out the square root on the right. So on the left, we would have 6 squared, which is 36, equals on the right side, we now just have x minus 2. And then you solve the resulting equation for your variable. So in this case, to solve for x, then I would just have to add 2 to each side. So then x would equal 38. But then before you actually say, okay, this is my answer, you should check it. Do I have to see that you checked it? No. But you should check it. I'll know if you didn't check it if it's a case where the solution doesn't actually work out. So just to check, and that could just be on your calculator, you just want to substitute the 38 in for x and make sure in this case that the right side does actually equal 5. So if I have 5 equals the square root of, I'm going to replace x with 38. Make sure, like I said, when I take the square root of 38 minus 2 and then subtract 1, that I get 5. So I know inside the square root, 38 minus 2 is 36. So I have the square root of 36 minus 1. I know the square root of 36 is 6. And 6 minus 1 is 5, so it does work out. So then I know 38 is my answer. If it didn't work out, that would mean my original equation wouldn't have a solution. Since this was the only solution I found, if it wouldn't work, I would have no solutions then. Or no real solutions, I should say. Any questions on A? All right, then for B, we're going to go through this one together as well. There's 2 square roots. So that first step, again, is to isolate the radical on one side of the equation. So if you have a radical on both sides, you just want to make sure one of them is by itself. In this case, the square root of x plus 15 is already alone. You also want to make sure that the two radicals are on opposite sides of the equal sign. That's going to make it easier to solve it. So if we already have one of the two radicals by itself, we can then go on to the second step to get rid of the radicals. So to get rid of the square root, I want to square both sides. So on the left side, square root and the square just cancel. I have x plus 15. On the right side, careful here, I cannot distribute that exponent of 2. This does not mean I square the 5 and I square the square root of x. What does this mean? Or how would I simplify 5 plus square root of x quantity squared? Yes, I have to FOIL it. This means 5 plus square root of x times 5 plus the square root of x. So you have to FOIL. You cannot distribute that exponent. So I'm going to keep, my left side is still x plus 15. I'm going to FOIL the right side. So I have, for the first terms, 5 times 5 is 25. Middle terms, or I should say outside term, 5 times the square root of x is plus 5 square root x. And then inside terms, I have square root of x times 5. That's another plus 5 square root x. And then last term, square root of x times square root of x is what? It's just x. So it wouldn't be 2 square root x. It would be the square root of x squared, which is just x. Okay, but then I can combine these two middle terms, the 5 square root x plus 5 square root x. Those are like terms. So I have x plus 15 equals 25 plus, this would become 10 square root x plus x. And now, because I had to FOIL, I still have a square root in my equation, so I have to go back now to step 1 and get that radical by itself. In order to cancel it out, I need to get this by itself first. So what I'm going to do from here is I need to get rid of this 25 and this x that are being added to that term. So I'm going to subtract them both in the same step, subtract 25 from each side, and subtract x from each side. And actually that means then the x cancels out on both sides. So on the left side I just have 15 minus 25 is negative 10. And then I have 10 square root x on the right. And then I can divide both sides by 10. Since that 10 is being multiplied by the square root, so I get negative 1 equals the square root of x. And then to solve for x, I would square both sides. So I'll have negative 1 squared is 1, and then square root of x squared is just x, so I get x is equal to 1. And then again, like I said for the first one, make sure you check. So this means in my original equation, if I'm going to substitute in 1 for both of the x's on either side and make sure they come out to be the same number. So I would have the square root of 1 plus 15. I want to know, does that equal 5 plus the square root of 1? So on the left, I have the square root of 16, which is 4. On the right side, I have 5 plus the square root of 1 is 1, and 5 plus 1 is 6. 4 does not equal 6. So therefore, x equals 1 is an extraneous solution, meaning it works in the equation I got after I squared both sides, but it doesn't work in the original. So this is not actually a solution, and since that was the only one I found, This means that my original equation has no real solutions. So like I said, I don't have to see your check, but in this case, I would know if you didn't check, if you're still saying that 1 is the solution to that equation. So you don't have to write it out, but at least check on your calculator, does it work? Okay, are there questions on example B for example 1? Okay, so then those are both equations that contain square roots. In example 2, it says solve this equation, 2 times the quantity 6x minus 3 to the 1/3 power minus 4 equals 0. Notice this equation, the way it's written, doesn't even have a radical in it. However, what does a 1/3 power mean?
You're going to multiply it by 1, but you're going to have it over the square root of it.
Okay, so it's going to be, I think you are on the right track. The 1/3 power means the cube roots.
Yeah, I was going to figure out, what's the 3?
Okay, so I could rewrite this so it has a radical. So this would be 2 times the cube root of 6x minus 3. And then I have minus 4 outside of the radical equals 0. Okay, so I'm going to be solving this equation for x. So my first step again is to get the radical by itself. I need to get this cube root alone. So I'm going to add 4 to both sides first. So I have 2 times the cube root of 6x minus 3 equals 4. And then before I try to get rid of that cube root, I need to get rid of the 2 in front that's being multiplied. So I'd have to divide both sides by 2. So the cube root of 6x minus 3 equals 4 divided by 2 is 2. And then I need to cancel out a cube root, and how do I do that? Cube everything, or raise both sides to the 3rd power. So whatever your index is on your radical is the power everything should be raised to once you get the radical by itself. So the cube root and the cube cancel out. And we have, I'm just going to continue this over here, we have 6x minus 3 equals 2 cubed, which is 8. Then to solve for x, I can add 3. So 6x equals 8 plus 3 is 11. Divide by 6, and I get x equals 11 over 6. Okay, leave it as a fraction, because when you divide by 6, you're going to get a repeating decimal, and if you write a repeating decimal and try to plug it back in to check it, it's automatically not going to work because you rounded your answer. So we should check this before we actually say it's our answer. And you could check it into the original, or you could even check it if you wanted the radical form. That would be fine. So I'll plug it back into the radical form. So 2 times the cube root of 6 times 11 over 6 minus 3, and then minus 4 on the outside. I want to know, does that actually equal 0? Okay, so if I work through this to simplify it, what is 6 times 11 over 6? Just 11. The 6's cancel. So we have 2 times the cube root of 11 minus 3 minus 4. 11 minus 3 is 8. What's the cube root of 8? Cube root of 8 is 2. So this is 2 times 2 minus 4, which is 4 minus 4, which does equal 0. So it does check out. So 11 over 6 is the solution to that equation. But again, you could use a calculator to check that as well. Just make sure that you are checking. So then example 3 on the top of the next side, I'd like you to work through. Find a solution, make sure you check it. But solve example 3. It has a 6th root in it, but you can follow the same methods we were using for the other examples.
Calculator.
Yeah.
Thank you. All right, I know some of you might be finishing up the example, but you can check once you're ready. Okay, so it's kind of nice in this section, or in this lesson, we're kind of going back to solving equations. You just have to make sure you understand how to get rid of the radicals. That's the new part of it. Are there any questions on example 3? All right, and I saw some of you are working ahead for example 4, the inequalities. When you solve a radical inequality, there are, again, 3 steps. There's an additional step, I would say. It's not exactly like solving a radical equation. There is an additional step that deals with the domain of the radical. So it says in step 1, and all of the inequalities you're going to be solving in this section will be with square roots. So step 1 will apply to every problem that you solve for inequalities. It says if the index of the root is even, you identify the values of the variable for which the radicand is non-negative, and non-negative means that it would be greater than or equal to 0. So 0 or positive. So it's as if you have to find the domain of the radical term first, because you have to make sure x is not a value that would make the square root negative. And then you solve the inequality just like you would solve the equation, or as if it was an equation. And it says to test values that you can use to check your solution, but what you're doing is then you're putting together the inequality you got from step 1 and the inequality you got from step 2 to get your full solution. So if we look at example A, so when you solve, this is where I recommend you start. You first, or what I would do first, is take what's in the square root, and this is how we found domains of square root functions. Whatever is in the square root, in this case it's 3x minus 6, it has to be greater than or equal to 0. You can't have an x value that when you plug it in you get the square root of a negative, because that's imaginary. Alright, I need your attention up here. Thank you. So make sure that this is set greater than or equal to 0 and solve that first. If, say, you were to forget this step, thinking ahead to your test next week, this really gives you half of your solution, so you're missing half of the problem. So make sure you're not forgetting this step with inequalities, and that just takes practice to make sure you don't forget it. So if I solve this for x, I would add 6 to both sides. So 3x is greater than or equal to 6. And then divide by 3. So x has to be greater than or equal to 2. Okay, so that already eliminates any x values that are smaller than 2. That's step 1. So we're going to come back to this. This is part of our solution. And now the second step then is to solve the full inequality, just like you solved the equations. Okay, so I'm just rewriting the inequality. Solve this like I would an equation. So I'm going to get the square root by itself, subtract 4 from each side. So the square root of 3x minus 6 is less than or equal to 7 minus 4 is 3. And then to get rid of the square root, I have to square both sides. So on the left side, I have 3x minus 6 is less than or equal to 3 squared is 9. Solve for x. So add 6 to both sides. 3x is less than or equal to 15. Divide by 3. X is less than or equal to 5. Okay, so then your solution set is the union of these two inequalities. So that's why you need both. So the solutions for x are x values that are greater than or equal to 2 and x values that are less than or equal to 5. Which there is another way to write this if you picture on a number line. If you wrote your answer like this and left it, this is perfectly fine. It is correct. But if you picture on a number line, I'm just going to put 2 and 5 on here. So going back to chapter 1 when we reviewed how to solve compound inequalities and then graph them. So if you have x values greater than or equal to 2, so you'd have a dot on 2, and then less than or equal to 5, you'd have a dot on 5. Greater than 2, less than 5, where they overlap is in between. So this means x has to be a number in between 2 and 5. So you could also write your solution set this way. So either of these forms would be acceptable. They will always be joined by and. It will always be the first inequality you found and the second inequality. But you can then condense your solution by either writing it in this form or, different examples, different things come up. Any questions on that one? You can check your answer. You could check, okay, if I plug in a value between 2 and 5, does it work? If I were to plug in a number that is not between 2 and 5, make sure it doesn't work. So there are ways to check inequalities. It's not as straightforward as checking an equation, but you can still check. So I'd like you to work through example B. find the solution set for B, and when I come around to check, I'll pass out your assignment as well. It's always greater, because whatever's in the square root can't be negative, so it'll always be greater. Yep, they're both greater than. So what you can do, Grace, is you could write your answer like this, or if you picture, like if you have -1 and you have 7, and there's dots on both, if you're greater than -1 and you're also greater than 7, where they overlap is just numbers that are greater than 7. So this would condense to just be this. But I still would need to see in your work that you found that.
I have the same question too.
Oh, yeah. Okay, I'm just going to show this tonight. I'm going to stop the recording.